This conference will now be recorded.
Good morning, guys. Hope you can see my screen. Okay. So we'll see Docker and Kubernetes concepts. As I mentioned earlier, we will cover only fundamentals, but I will introduce you to all the concepts here. But labs cannot be done for each and every concept because it takes another 30 plus hours. Okay, but all the fundamentals will be covered and guidance will be given to you to do your own self-learning later. You don't need to join any other course for this. Okay, whatever I'm going to tell you will help you to do your self-learning as well. Okay, so first let's see what is Docker and what is Azure Kubernetes Service. Okay, so what are the Docker's fundamentals? I mean, it's very important to have a base, right? So what is a Docker? So if you see the definition, Docker is a container management service. It's a platform basically. Okay. The purpose of Docker is for developers to easily develop applications, build images, and ship them into containers, which can be deployed anywhere. So you see two keywords here. One is Docker, and another one is container. Okay. You need to. So if I have to apply some analogy, your code is your Visual Studio. The code that you develop in Visual Studio or Java, you think of it as a .cs project, right? You think of it as a Docker, and once you build it, you have the artifacts. What is that? That is your DLL, right? That you can think of it as a container. That means the non-executable version is your Docker, and executable version is your container. I'm just giving some analogy. It may not be perfect, but to make you comfortable, I'm just giving you that example. Okay. So it is saying we can develop application, build images, ship them into containers, and can be deployed anywhere. That is the keyword. Can be deployed anywhere. That means before I explain this, let me tell you. So let us say you develop some .NET application, okay, and you deploy it in some development servers. It works well. When you deploy to QA servers, what happens? Sometimes it may fail because of the configuration issues. That means your dev server's configuration could be different from QA server configuration, and then your UAT server config could be different from QA servers, like that, right? Because of these issues, even though there is no change in your code, it will keep failing in all different environments. There is a possibility, high possibility. Okay, that is one problem, right? So with the introduction of Docker, you will be resolving that issue. That means once you create a Docker image for your code and convert into container to run from Docker platform, you will not see the environment issues, because all the environment issues like server configuration issues, etc., will be abstracted by Docker platform. Means we install the Docker on top of our existing operating system, and into the Docker we will deploy the images, which will run as a container, and Docker will take care of all those issues. So your developer or an administrator is free from environment issues. Okay, so that's about Docker. So the benefits I just explained. You can develop anywhere, you can ship anywhere, means you can deploy anywhere, and you can run anywhere without any issues. Your application will run as long as it is in Docker container. Any doubts on the definition? We will see why, how, etc. But at least do you understand the definition now? Yeah. Can you tell me if you're on mute, come out, and it's important to understand this Dockers and containers. Are you good?
Yes, Purna.
Yes, Purna.
Okay. Now you need to understand all the different building blocks of your Docker as well. Let us say when you are learning some programming language or a scripting language, what are our building blocks? You need to know the syntax and semantics. Syntax means how you will write it, and what you need to write it, right? So when you learn PowerShell, you learned variables, you learned loops, conditions, and some key commands, and then how to use commands. All these things you learn, means all the building blocks of your scripting environment, like your PowerShell. And now you know how you learned it. Now you can apply the same analogy to learn any other programming language as well, or any scripting language as well, because you know exactly what need to do. Similarly, you need to know what are the basic units of Docker. I mean, I would say, what are the building blocks of your Docker basically. As I said, Docker is a platform. Okay. Image. The first building block or basic unit is image, the actual content and basis for the container. As I told you, if I have to apply analogy, your .NET code is a image. Okay. And once you run it, once you build it or compile it, you get DLL, that is a container. Okay. Similarly, for your code, we will create an image basically based on some using some Docker commands. We create an image, okay, that contains all of your code, okay, all your .NET code, and also it requires some IIS, right, to run. So that IIS will also be embedded into this image basically. So basically, it is a minified version of your IIS. That means if you have to install IIS manually on a server, if it takes 1 GB, whatever is going to be in your image, that IIS size might be in MBs. Okay. What else is required to run your .NET application? We need ASP.NET runtime as well, right? We install the .NET, right, on our servers as part of Visual Studio. So that ASP.NET runtime will also be embedded into image basically. That means in a single image, you need you will have all the software that is required to run your that is required to run your image as a container, so that end users can access the applications running from the container. Okay. Now, what is a container? As I said, it is a running version of image, nothing but actual executable. Okay. Another example I can give. So you get an MSA, right? You get an MSA to install any software, MSA file. One, so when it is just an MSA form, you cannot user cannot access any application that is packaged in that MSA. But when you run that MSA or EXE, what happens? It will install the actual application and the users can access the application. So similarly, container, it is a running version of your image and it is an executable basically, so that end users can access the application running inside the container. How that container is made? That is from the image. So there are multiple commands to create the containers. And to run your container, you need a platform, right? So that is a Docker platform. You call it as a Docker engine. Docker engine. It is a piece of software where you can execute Docker commands and you apply the networking. Volume is nothing but your storage, etc. Part of the engine, Docker engine. That means so we will see some differences. Why I am saying it is a Docker engine. We need to do a networking. Networking means the firewall ports to be open, like when you install a virtual machine, I open the ports like HTTP and HTTPS, right, port 80, port 443, and some other ports like for PowerShell and RDP, etc. Similarly, you need to do the same thing in Docker container as well. That you call it as a networking. There you have a disks, right? C drive, D drive, etc. Here you call it them as volume. Okay, in Docker terminology. You will understand why I'm talking about in Docker in the later slides. What is other basic unit? Container registry. What is container? It stores, manages, and distributes Docker images. Okay. The way you have Azure repos or GitHub to manage your code as a source control management tool, you will have a container registry to manage your images, because I'm creating images based on the code what you have, and I need to store it somewhere else. That somewhere else is your container registry. Okay. Similar to your SCM for regular code. And what is the other one? Control plane, orchestrator and management plane for containers. So to manage all your images and their containers, etc., and to manage your networking volume, etc., part of your Docker engine, you need some UI as well, right? Okay, you cannot do it simply from the command prompt. It is time consuming activity. That's the reason you need some portal as well. Okay, like the way you are using Azure portal for cloud administration, etc. So here you call it as a control plane. So you will have some portal, Kubernetes portal or Docker portal as well, okay, to manage it. So these are the basic units: image, container, Docker engine, container registry, control plane. You need to understand all these things. Any questions? Okay.
Puna, one thing. So this is
Uh-huh.
like having register points in the OS, right?
Yeah, I'm coming to that point. Just I'm going step by step. In the
Okay,
coming slides, you will see that. Okay.
sure.
Okay. So as I said, Docker uh, images are container. Your images can be converted to container. Container runs anywhere. The definition is like this, right? Build, ship, and run anywhere. So you can run these Docker images on Linux environment or Windows environment, and those softwares on the servers can be from your own data center or can be cloud. Doesn't matter. Okay. And nowadays, sorry, it is little old diagram, so even Mac as well you can run your images. Okay, all three operating systems. Now you see the journey of containerized application. So if you don't know the fundamental, you will lose the context basically. So though you might be deploying and executing some commands, you do not have the grip. So you need to understand the journey, how this infrastructure evolved basically. So if you remember, we all started with the physical servers, right? Where we buy the server hardware and keep it in the data center, and we will buy the networking cable, AC units, and you will buy the storage units, and you have different teams. You have server administrators, network administrators, and antivirus or security administrators, and storage admin. All these people work together, and electricians as well, right? All these people work together to make your server available, so that developers will go ahead and deploy their applications, and end users can access the application from those physical servers. This is all what happens, right? Imagine how much time it may take to create a physical server, to procure a physical server and install it and configure it. Okay, it may take a minimum once, as I mean think that your funding is already approved in your company to buy a server. From there it may take a minimum 2 to 3 months to get the server from companies like Dell, HP, etc., and put it in your data center and install it takes minimum 2 to 3 months. Okay, coming to the virtual machine, how much time it will take for you? It hardly takes a couple of minutes for you to create a virtual machine, right? So that's the difference. I mean, the main difference, the speed to market of the company will be improved a lot when you use a virtual machine. So as I said, after physical machines, you got the virtual machine. The concept of virtual machines brought up by VMware, if, to my knowledge. So generally, people install VMware software on the physical servers. After they install that software, they will be able to create virtual machines on top of the physical servers. Not it is as simple concept is that you will have a bigger box like this. Is think of this box as a physical server. Okay, on top of, and like this they will have a n number of physical servers. What people will do, will they will install the VMware software. Using the VMware software, people will be able to partition this physical server. Let us say this is 128 GB. This server capacity is 128 GB RAM and 1000, let us say 10 terabyte data. What people can do, they can make 8 GB RAM virtual machines, 8 GB, 8 GB, 8 GB, 8 GB. So, so when they make 8 GB capacity virtual machines, you will have how much? You will have 128 by 8, right? You will have more than 1230. So they will partition the physical server and create a virtual machine and give it to the end users basically. So that's how your virtualization works. Be it Azure Cloud, be it they might be using different software for partitioning, but this is the concept. So you have the physical servers, and then we move to the virtual machines. where you have your VMware, if it is on-premise, and if it is a public cloud, you have AWS and Azure and GCP, right? And after that, we have the containerization. Now we are in the era of containerization. Now we are talking about creating the Docker containers to deploy your applications and make it available to the end users. Why say it's all about speed? Okay. Now from 2 to 3 months of setting up a server to we came to 2 to 3 minutes of creating virtual machine. That is about installation configuration. Let us say that your application is running from two servers behind a load balancer. Now these two web servers will be able to serve 1,000 requests per second. Just imagine 1,000 requests per second. Okay. What if the load is increased? Let us say you take example of IRCTC, right? On IRCTC on a festival season, the number of users will be increased like dramatically, right? If it is 1,000 requests per second on a regular day, during festival days it could be 1 lakh requests per second as well. So then what they have to do, they need to increase the capacity of their environment. That means if they are running, example, let us say if they are running 10 virtual machines, they may need to increase it to 20 virtual machines or 40 virtual machines. Okay. And all this should happen dynamically, right? On demand, because you never know when the user's load will be increased. If you create in advance, what happens? You are spending the lot of money. But if you are creating on demand, some of the request might be failed. Basically, let us say the virtual for the virtual machine to be created in the background, it may take a couple of minutes, at least 2 minutes it may take, because it's a heavy machine, right? You will have a operating system and everything. But in the 2 minutes, there is a possibility of failed request from the end user, because if you create, if you access your application, the server might not be ready in the 2 to 3 minutes. There is a chance of failure. But to mitigate this, what our companies will do, they create virtual machines in advance. They expect it, right? Okay, from tomorrow, the number of requests will increase. Like that, they guess and they create it. But that is not effective cost optimization. You are spending though you are not using it. That's where you come to containerization. So it is on top of your virtual machines or physical servers. So to create a Docker image hardly takes couple of seconds. So if it is physical servers, it takes months. If it is a virtual machines, it takes minutes. If it is a Docker containers, it takes hardly seconds. So your users will be unaffected. So that is another advantage of your containers. Basically, your speed to market or availability of application will be increased, and your cost will be reduced. Okay, we will see why the cost will be further reduced. Okay, uh, so that companies will be on the beneficiary share basically. Okay, so if you see the legacy environment, this is how it looks like. So you will have hardware infrastructure, that is you buy you the server. On top of that, you install the operating system. On top of that, you have your applications and you will have your softwares running. It could be your MS Office. It could be your IAS. It could be Apache Tomcat, and then you will have all the libraries, reusable components, or some other software, and then you will have your applications. Right. This is how your legacy physical environment looks like if you are using a physical server. Any doubts? How you moved from physical to virtual to containerization, and what are the importance, some benefits of the containerization? Any doubts here?
Basically, now everyone is using containers only.
Not everyone.
Okay.
See, hardly 5% of the, or less than 5% of the people are using it, because it requires a learning curve. Okay, uh, it requires a learning curve, and also your applications should also be re-architected to make use of containerization benefits. Let us say, as I said, if you deploy them into containers, your cost of infrastructure will be reduced. That is point one. And point two is that you will be able to spin additional containers on demand to serve the increased number of requests within a less than a second or a couple of seconds. Your speed to market, spinning up the container will be very quick. But to get to that level, your applications have to be re-architected. Most of the applications are not in a modern architecture. They do not follow any application architecture patterns or design patterns. They do not follow. They simply create a code and push it to the servers. So that's the reason all the companies are now realizing their code is in a bad shape. So that's the reason it is taking time to adapt the containerization. Now you see most of the product companies, okay, they always keep their architecture clean and neat. Means the architecture of the application should also be extensible and configurable. Extensible means it has to be modularized. It has to be plug and play. The architecture should be flexible, and that is the reason most of the companies are not able to meet it. But what they are doing, whatever they're writing newly, they're trying to use containerization, because most of the companies are burdened by the deadlines, right? Everyone says that I need it in the next 2 days, next 3 days, next 4 days. If your time is a constraint, you cannot develop a very good application with a very good architecture. If you don't have very good architecture, it doesn't make sense to go to containerization. We'll tell you why that matters. Architecture patterns are very important, okay, to make use of containerization. But I'm sure in next 5 6 years, at least 40 50% or more than 50% will be on the containers, to my knowledge. Okay, it's not any study.
Okay.
So let's see the differences between virtual machines and containers. So you can call it as a Docker container or container, okay? But let's see the differences. If it is a virtualized application environment, how it looks like. Generally, you will have a hardware infrastructure. On top of that, you have operating system. On top of that, you have a hypervisor. Hypervisor is a software which partition your physical server into multiple virtual machines based on the capacity. As I said, if it is 120, if it is, let us say, 32 GB, or 64 GB, your hypervisor, in our case, let us say, you can think of it as a VMware. Okay, I'm just giving an example. That will be able to create you know uh, 5 virtual machines of memory, 8 GB each, like that. I mean, it will do some calculations, it will create virtual machines, okay. And on top of that, we have the virtual machines. Each virtual machine is a server on its own, right? You see, on top of physical server, you have multiple virtual. If you take this this block alone, you have a physical server, but inside you have two virtual machines running. I'm just giving you an example. And again, see, the underlying underlying operating system could be Linux or could be Windows, but you can create your own operating system server, right? It can be Macintosh, it could be Mac, it could be Linux, it could be Windows. That's why we call it as a guest operating system. This operating system on the physical server, on top of it, you have hypervisor, on top of you have virtual machine. Inside that you have your own operating system, Linux or Windows or Mac, anything. And this is as usual. You have your applications, your dependencies, your softwares, your reusable components. Everything will be inside a virtual machine. Clear how your virtual machine looks like on top of physical server.
Yes.
Okay. Now, if it is containerization, how it looks like. So basically, if you think about, last two boxes are the physical servers, and top one is related to your virtual machines from three and top. If it is a containerization, obviously you need a hardware infrastructure. Obviously, you need an operating system on top of your server hardware infrastructure. That infrastructure will contain your networking, storage, and all that stuff as well. When that's the reason I did not say server. I did not say. I said infrastructure, because simple server will not work, right? You need a cables, storage devices. and everything. Okay. Now if you see, on top of operating system, your Docker is running. Guys, I did not mention hypervisor after the operating system because you might be running your Docker on a physical server and a virtual server, right? It can be on a physical server, it can be virtual server, because you just need to run the Docker software. That's it. Okay, that's the reason I did not give hypervisor here. I simply given Docker on top of operating system. And then you have the containers running. Okay, so so think of it as a your physical server basically. That's the reason you don't see another box. It will become clumsy if I show the container inside a virtual machine. It will become clumsy, means it won't be readable. So I took the concept of physical server and the Docker container. So you have operating system on top of Docker. You have the Docker software. Inside that you have the containers. So if you see application dependencies libraries, here also you see application dependencies and libraries. Means your container itself is a server, but it is a minified virtual machine. You can think. So minified version of your virtual machine. Let us say if your virtual machine size is 10 GB, your container size hardly comes to MBs. Okay, that means it doesn't contain all the software that is required, the full versions of the software. It contains only what it is required. Let us say when you create a virtual machine, you have a lot of software that is installed on your virtual machine. But what all I need for my .NET application, I just need IIS and your some parts of your operating system and some libraries. That's it. But I'm using full server to just run my simple application. Let us say I created 8 GB RAM. Do I really need a 8 GB RAM to create my hello world application? It hardly needs MBs. That means I'm wasting my infrastructure here. Okay. So if it is a virtual, if the container is in the virtual machine, you can simply visualize on top of operating system, you have a hypervisor, you have the virtual machine. Inside the virtual machine, you will have the Docker. Inside the virtual machine, you have the Docker, and inside the Docker, so this entire the first big box and second big box will get inside the virtual machine on top of the guest operating system. Clear how it is? I mean, how it looks like. Any doubts here? Yeah, please ask me doubts here because it's important to understand this.
Purna, one question.
Mhm.
So in the virtual machine you mentioned as general operating system, but in
Guest,
container,
guest, not the general guest operating system. That is the
guest
terminology.
operating
Guest
system.
operating system. Yeah.
Okay, what's the difference actually?
See, that is just a name basically. Because your physical server already have a operating system. On top of that, you have a hypervisor. On top of that, you are creating virtual machine, right? In Azure Cloud, you go and create a virtual machine. There, you can select your Linux operating system or Windows operating system or Mac operating system, right? Okay.
Yes.
That the terminology that you use to refer to that operating system is a guest operating system. That's it. And
Okay.
the bottom one, on the physical server, whatever you call it as a host operating system. You call it as a host and you call it as a guest. That's it. Nothing but
Okay.
this server is hosting all the servers, right? All the virtual machine. Getting it? It's just
Okay.
a terminology to refer to. Okay.
Yeah, fine.
Okay. So if these Dockers are in the virtual machine, as I said, you can replace this. On top of the guest operating system, you will have your Docker. On top of that, you will have the container. As simple as that. Okay. So I was talking about when I said container, I was talking about okay, your image itself, image will be converted to container, right? You remember it, okay? Your image or container contains your IIS, your .NET runtime, and then your application code, and it's a reusable components, whatever it is, right? But what about operating system? I did not say that I will install a operating system inside the container as well. So then how it takes the operating system? So via Docker, it will utilize the kernel of your operating system in the bottom, host operating system basically. Okay, kernel, I mean, this is very technical, but what you need to understand, this Docker software or a Docker platform will will make this host operating system available to your container, but it is only at the kernel level, not the entire operating system. That's the reason we don't embed operating system into the image. We don't need it, because if it is also there, then it will also become bulky. It will become huge. Again, it will, to spin another container, it will take more time basically. Your speed to market will be affected. Make sense?
Puna, this
Yeah.
uh, you said it uses the kernel, but
Mhm.
I require another, I mean, operating system, guest operating system, not the same as that of the host operating system.
Mm-hmm.
Then
Yeah. So, okay, here you see, right? Let us say now we are almost into cloud, right? Okay.
yeah,
Even if the people are running Docker images or Kubernetes, it will be on the cloud only mostly, because if you want to spin another virtual machine, it takes months, right? In the hardware. I mean, if it is a physical, that's the reason people are using their public cloud or private cloud. Private means your VMware. Okay. I explained in the initial sessions. Okay, they basically run now containers inside a virtual machine. So simple funda is that if your virtual machine software is that, after operating system is Windows, you need to run the Windows containers. Okay, if it is Unix, you will run the Unix containers. Okay, but the effort is being made by the Docker to make it transparent. It doesn't matter what operating system your virtual machine will contain. You can run Unix based containers or Windows based containers. That effort is being made basically. But you don't need to worry about in the background basically. Everything will be taken care by Docker. You just need to create an image and convert it to container to run inside a server. Okay, it can be virtual server, it could be a physical server. Okay.
I mean, operating system doesn't play that much role in the Docker. What you
No,
said.
see, operating system should be there, right? Otherwise, how we were, see, you are installing a Docker where you are installing on top of some operating system, right?
Yeah,
What
right.
I'm saying, Docker will take care of all the issues or connectivity stuff between your container and the operating system. That's what I'm saying.
Okay.
This is the middleman. It will, so the the funda here is that, right? You build, you create an image, you build anywhere and run anywhere, right? How it is becoming run anywhere or build anywhere, that is because of the Docker will take care of underlying operating system configuration issues when you are using Docker containers. Okay.
Okay.
Okay. So now let's see how production environment looks like typically, right? A typical production environment. So it basically, if you take any production environment in any bigger company, it is a combination of your physical servers. Some applications might be running from your physical servers and in your own data centers. Some applications might be running from AWS. Some applications might be running from Azure. Some could be from GCP, I mean Google Cloud, and some could be on top of Docker. And the Docker could be running from Azure virtual machines or AWS virtual machines on your own physical servers. This is how your typical production environment look like, right? We go to any company. So the I'm just trying to show it here. Okay, virtualized application environment. So this is what is, right? Hardware, and then operating system, hypervisor, and then some applications might be running on the virtual machines, and some applications might be running on the containers. Now you can see in the previous slide, I did not show this view basically. Dockers are inside a virtual machine. Now this is how your Docker inside a virtual machine look like. You see containers inside a virtual machine. You have the guest operating system and then Docker on top of that. All the I mean the images that are running in terms of container basically. You see app A, actually this is app B. So your actual production environment is a combination of your physical servers, virtual servers, and then your containers. You go anywhere. This is how it looks like. Okay. Now, containerized applications or services. See, if you are having containerized applications or services means you can think of it as APIs. Okay. So you have hardware, operating system, Docker. On top of the Docker, you have the applications A, application B, application C, and application D. And what are the benefits? Your build, deployment, and configuration will be standardized. And these are lightweight. As I said, to create a physical server, it takes months because you have to buy the hardware and install, configure, etc. To create a virtual machine, it takes minutes. To create a container, it takes seconds because these are lightweight. And then isolated means if something, let us say, if you take virtual machine, I created two virtual machines in my Azure cloud. If my virtual machine one is corrupted, does it affect my virtual machine too? No, right? Both might be running on the same physical server, which you don't see, you never see basically. Both might be running on the same physical server. Still, my virtual machine one issues will not affect the virtual machine two. Similarly, though my apps A, B, C, D are running on the same Docker on the same server, the issues in app A will not affect app B, app C, or app D because these are isolated and secure. The way your virtual machine is secured, in the same way your container is also secure. You have all your networking, firewalls, and everything. Whatever is there applicable to your hardware, I mean physical server, is applied to your virtual machine. Now all those things will be applied to your Docker as well because it's just a box inside a box, right? These are the benefits of your containerized applications. Standard, lightweight, isolated, and secure. So if you want to look at the definition, a container standard unit of software that packages up your code, your .NET Core or Java code, and all of its dependencies. Means your if it is .NET Core, you need AKS. If it is Java, you need Apache Tomcat, etc. And you need access to the server, and it should have some volume as well, like your storage, etc. Okay. So I mean, so all its dependencies. So the application runs quickly and reliably from one computing environment to another environment. So you will not get into any environment issues. Okay, you don't need to worry what version of software server is running in QA, what version is running in production, etc. It will be taken care by Docker. And after that, now you know what is a Docker, container, building blocks, differences between physical servers, virtual machines, and then containers. Means Docker basically. Now let's understand what is a container registry. So in the previous slides, you see in the building blocks, container registry is one of the building block. What is this? It is to manage your images that are built on top of your existing code basically, source code, right? So that's what I say. Container registry is a place where the images are being managed, stored, and distributed for use by applications. So similar to your SCM for your code, container registry is for your images. So there are many vendors so for container registries. So if I have to apply the analogy, to manage your source code, you have your Azure repos, you have GitHub, you have Bitbucket, you have TFS, you have Akira, you have Serena Dimensions. There are hell number of SCM controls, SCM tools. Similarly, in container registry, there are many vendors. Obviously, Docker Hub is the company who created or invented this Docker platform. So they have their own container registry to store the images. That is Docker Hub. And he is the creator of Docker Hub. Docker is the creator of Docker platform. So whatever the other companies are developing, be it Azure or AWS or GCP, they're all basically extending the software created by Docker basically. Okay. So Docker Hub is the container registry for Dockers from Docker company, and AWS ECS Elastic Container Service from the AWS, and Azure Container Services ACS from the Azure. So since we are learning Azure DevOps and then we are using Azure Cloud, we're going to use Azure Container Service for our fundamentals demo as well. And in our building blocks, we have the orchestration and engine kind of stuff as well. So you need to have some mechanism to manage your containers, right? Like to build, to deploy. Once you deploy, to manage them. Let us say if you take a cloud, if some virtual machine is corrupted, what you do? You may log into your portal.azure.com and you shut down it. If it is not automated shutdown, you may manually shut down it. If you need to do some troubleshooting, you log into that portal.azure.com or directly log into virtual machine and do. And you can do many management activities from the portal.azure.com itself if it is Azure Cloud. Similarly, we need an orchestrator that you call it as some portal, right? Which is nothing but your orchestrator where you are doing something. Here in Docker and Kubernetes terminology, you call it as an orchestrator. Orchestrators are for automating the deployment, scaling, and management of containers. Scaling means scaling out your containers based on the number of requests. It might be 2 containers now running, but based on the request, it may need to be increased by another 3 or 4. That is called scaling. Deployment, how to deploy. Management, to manage your containers, making changes to the containers, updating the containers, etc. etc. There are various orchestrator platforms. One is Docker Swarm to manage your container. Obviously, Docker is the company who invented. They have their own orchestrator. We call it as a Docker Swarm. And then Mesosphere DC OS. This is another company's orchestrator. And then Kubernetes. Okay. Docker did not become famous, or containerization did not become much famous when it is only with the Docker basically. When the Kubernetes came into picture, it is invented by these guys, Google basically. They created this Kubernetes platform based on this Docker Swarm and Docker concepts. Okay, and they made it very secure, reliable, all that architecture patterns basically, and that's where Docker became very famous. So Kubernetes will be used to manage your to deploy or scale or manage your containers basically. It is an orchestrator platform. Kubernetes became very famous, and many vendors came and they created their own wrappers on top of the Kubernetes of the Google Cloud. Because to learn Kubernetes and to install and configure Kubernetes and to use Kubernetes in your company, it takes a lot of hard work in terms of learning and implementing it. That's the reason many people created their own wrappers on top of Kubernetes. So one such is your AWS Azure AKS, Azure Kubernetes Service. Similarly, on AWS, you call it as EKS, Elastic Containers Kubernetes Service. Okay. So what this will do, if I have to set up some Kubernetes cluster, right? Cluster means nothing but a group of servers. Okay. If I have to install and configure group of servers inside a Kubernetes to run my containers, it takes 6 months to 1 year as well to just create a cluster. But if it is a managed version of Kubernetes, like your AKS or EKS, it takes hardly minutes. That's the reason all these vendors create a wrapper on top of Kubernetes. So this is your container orchestrator platform. Any doubts?
No problem.
Okay. So now, so far you understood the basics of Dockers. Now, to manage your Docker containers, you need to know you need to have some orchestrator platform. Kubernetes, one such orchestrator platform. Others are Docker Swarm and Mesos, and there are many as well. Even I don't know. Okay, but these are very popular. Kubernetes is the most widely used orchestrator platform. Okay. Now, what is this? Kubernetes is open source. That's the reason people are able to create their own wrappers on top of Kubernetes. So it is an open source system for automating deployment, scaling, and management of containerized applications. So another name for Kubernetes is K8. So if you are working in any company in a production environment, if you are a professional Kubernetes guy, many of the times you refer it as a K8. You can say the K8 basically. This is another name. And what are the important features of Kubernetes? Storage orchestration. It will take care of your storage, means your disks and external storage, etc. Service topology, how the components should be deployed, how they are connected. All the underlying infrastructure connectivity will be taken care by Kubernetes. The developers will just need to deploy their application, developer or administrator. Okay. Service discovery and load balancing. The way you have load balancers in your virtual machine or a physical machine environment, in the same way you will have the load balancer in containers as well. As I told you, container is a minified version of your virtual machine. Virtual machine is a minified version of your physical server, right? So whatever the concepts are applicable for physical servers are applicable for virtual machine. Concept means your storage administration, network administration, etc. Okay. And whatever is applicable for your virtual machine are applicable for your containers as well. That's the reason we're talking about storage, we're talking about service topology like networking, and then load balancing and self-healing. This is another advantage. Self-healing means if some container is corrupted, what happens? It will automatically destroyed and a new instance of your image will be created. New instance means container. Okay. Another container will be created. That's what self-healing. But in a virtual machines, another virtual machine will not be created, right? If something goes wrong with that virtual machine, you have to do something, isn't it? So that's what self-healing. And that self-healing capability is available in the Kubernetes itself. And secret and configuration means, I mean, all your user IDs or passwords can be managed as a secret in Kubernetes when you are using the containers deployed inside your Kubernetes. Again, Kubernetes is a piece of software. Okay, you will install the Docker, that is a prerequisite, and then you will install the Kubernetes. Horizontal scaling. Scaling, you have two types of scaling: scale out and scale up. Scale out means horizontal scaling, means if you have one container, you will make it two containers, three containers. That is a scale out or horizontal scaling. The other one is scale up or vertical scaling. Scale up or vertical scaling means increase the capacity of your container. Means if it is having 2 GB RAM, make it 4 GB RAM, like that. The same concept applicable for your virtual machine, or of course it is derived from your physical or virtual machine only, right? Basically, if you want to increase your virtual machines, what you do? You will create another virtual machine. We call it as a horizontal scaling. But if you want to increase the RAM of the virtual machine, you call it as a vertical scaling or scale out. That's the concept. So those scaling facilities will also be made available by Kubernetes for Docker containers. So there are many different flavors of Kubernetes, but of course, why we need a Kubernetes is what here basically. It's ease of maintenance. It is easy to maintain your containers if you are using Kubernetes. It provides a security. It provides a control because you have a beautiful UI to control all your images, etc. And available resources. It will take care of. It will show, or it will give you a facility to handle all the resources around your Dockers, like your volumes, your images, containers, and different versions. Everything can be managed from the Kubernetes. And you need, you need some expertise required to operate. And see, it's not as simple as a high level program, right? You need to learn Kubernetes, and then you can become an administrator, you can become a Kubernetes developer as well. Okay, these are some requirements to use Kubernetes. And how your dev and production environment looks like when it is a Kubernetes. If it is a dev environment, let us say you as a developer, I as an administrator, obviously first need to test our images or containers and deploy them to local Kubernetes. Once you are successful, then only we will move it to the production environment, right? So how do you, so if it is virtual machines or physical servers, the concepts are simple. You will install IAS on your local laptop or your local server and run your application. If it is in production environment as well, you will do the same thing, but that will have bigger server, right? You may have 8 GB RAM server in dev or your local, but in production it could be 128 GB RAM. That's the only difference. But there also you install the IAS and run your application. But if when you come to the Dockers and Kubernetes, for the development environment, use a Docker desktop for Windows. Docker desktop is a software from the Docker to work with the Dockers and Kubernetes basically. If you are using previous versions of Windows 10, then you have to use Oracle VirtualBox. This is another software you need to install on your server if you are using previous version of your Windows 10 basically. But I'm sure right now everyone is on Windows 10 at least. I will show you how to install the Docker. It's a straightforward. Okay. And production environment options, there are many. Okay, before we get into production environment options, why not we see how to install a Docker desktop? It is like setting up your dev environment. So be it administrator or be it a developer, they need this. So simply go to Google and you say Docker desktop for mine is Windows 10. Okay, but don't use older versions because Docker is evolving every day basically. Okay, so the first one is docs.docker.com. Install Docker desktop on Windows. Click this. Okay, it will directly take you to this download Docker desktop for Windows. You can download this. It will tell you all the prerequisites, but most of our Windows 10s are having all these prerequisites like what operating system, etc., etc. You simply download this. You will get this exe. After that you just need to execute it basically. Whatever it will ask you, you simply say yes. Means when you install Docker, as I said, Docker will talk to your kernel of your operating system while it is running the containers, right? Image is image will be converted to container. Container is executable version, right? So container needs some access or some features of your operating system. As I said, Docker is a middleman between your container and operating system. That's the reason Docker needs access to your operating system. It is as simple as like when you are installing some app from your Android store or App Store and iOS, all apps will ask you, right? I need access to your contacts. I need access to your photos. I need your access to file system. It will ask you all those questions, right? Similarly, your Docker desktop will also ask the same question. Hey, I need access to your file system. You need to say yes, otherwise it cannot run. You getting me? Is that clear?
Yes, Kunal.
Hello?
Yes, Kunal.
Okay. So once it runs it, you can you can run, you can install, you can download and install it. And as I said, say yes, 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 yes. Right now it is run downloading. Let's get back. So that's how you set up the dev environment very easily. Earlier, 2 years ago, it was very difficult. It took almost 1 month for me to set up my dev environment using Oracle VirtualBox. Right now, it is a Docker desktop, very easy, simple one click basically. So production environment options. To run your Dockers and Kubernetes in production, there are multiple options available. Just before getting into this Dockers and Kubernetes options, if you take your regular environment other than your Dockers and containers, you have multiple options to run your applications, right? You can run your application from your physical data center, or you can run your application from public cloud like Azure or AWS, or a private cloud like VMware. And if you are a company, medium company, you cannot afford your own data center. There are companies which provides infrastructure on lease basically. Like there are companies like F5 etc. They basically lease hardware. The way you can lease the open land, in the same way you can lease the hardware as well. They will give you hardware. uh, they maintain the data center. They will give you access to their servers basically. You can go and run. So that is another option. Okay, if it is a physical machines or virtual machines. Similarly, you will have a different production environment options for running your Dockers and Kubernetes as well. The first one is managed version of Kubernetes. You can see some boxes are in a blue color and some are thick blue, some are light. You see, so but the options what you have is application, data plane, control plane, cluster infrastructure, and minimal cluster operations. Means administration basically. Okay, when you say managed, uh, let me put otherwise. So first, you have the managed version of Kubernetes and the on-premise version of Kubernetes and turnkey cloud Kubernetes, and the final is custom Kubernetes. Now you see the legend: managed by providers and self-managed. You see the legend, the thick navy blue, right? Managed by providers. If you see managed version of Kubernetes, okay, the data plane, control plane, cluster infrastructure, all these three components will be managed by the provider. Means if I am a provider like AWS or Azure. So if you are using Azure to use Kubernetes, you create a AKS cluster, Azure Kubernetes Service. So when using AKS, which is a managed version of your Kubernetes, then you are responsible only for deploying your application and minimal cluster operations. Application and cluster operation. That means you deploy your code and you manage what servers to be created, how much data to be, or how much compute capacity, means how many servers should be there in the cluster. Such kind of operations will be managed by you. Rest everything like underlying Kubernetes infrastructure, which may contain physical servers or virtual machines, or control plane like a UI and infrastructure operation. Everything will be managed by Kubernetes. I mean, your managed provider, means your AWS, Azure, etc. If it is on-premise, you own it basically. You own it. That means only the control plane is provided by your software. That means how do I run my Kubernetes in my own data center? I have to download the Kubernetes software from kubernetes.io website. So when I install that Kubernetes, what all I get from that software is only control plane. The portal only will be given by the software. Rest everything I have to take care. I have to take care of the cluster infrastructure, means underlying servers, and I need to maintain my physical servers, and I need to maintain my application code. I need to maintain data plane, all your storage as well. If it is on premise, all the efforts have to be done by you. If it is managed, only you take care of your application and some minimal administration activities. What is turnkey cloud? This is what I was referring to. There are some companies who will lease their infrastructure. You go and manage your applications. So that's what it is. If it is a turnkey cloud, so the companies who are providing that infrastructure will manage the infrastructure and they will install the Kubernetes as well. Okay, and you are responsible to self manage your application, control plane, and normal cluster operation. They don't allow you to manage their physical server, but to manage your cluster basically from a portal. And if it is a custom, that means you create your own wrapper on top of the Kubernetes, and you want to run it from your own data center. That's where you are responsible for all these five blocks. You are responsible for your application, you are responsible for data plane, control plane, cluster infrastructure, and cluster operations as well. So in our production environment, most of the people goes with managed Kubernetes version on AWS or Azure or on GCP, because they don't want to. Nobody wants to take care of the headache, like installation and configuration of Kubernetes and the maintenance of Kubernetes, because it is a hell lot of work basically. So that's why you see mostly managed. Even in my company or in my previous companies, initially we went with Kubernetes on-premise version, because that time all these managed versions are not matured basically, and we spent also years basically to make it up and running and doing some POCs. But right now with the managed versions, it became minutes basically. Okay, so these are the different production environment options you have, and most of the people or companies goes with managed version. I would say more than 90%. Clear? What are the different options available for your Kubernetes?
Uh, yes, Purna. Purna, I'm leaving.
Sure, sure. I'll continue another 5-10 minutes and we'll close it. We don't do any lab basically. Tomorrow we'll do. Okay.
Okay, okay,
So
okay.
I'm
Thanks.
just introducing to all the concepts because these are very important to understand. Okay.
Yeah, sure, sure. You can go ahead.
Thanks.
No.
And so now different options available for Kubernetes. And as I said, AKS is managed version of your Kubernetes. Means you are not using open source Kubernetes. Azure created its own version and it called it as AKS, Azure Kubernetes Service, and it is depending on your Kubernetes open source platform. So you call it as a hosted Kubernetes environment. So let us say if you want to create a Kubernetes cluster, you simply go ahead and create it. It takes hardly minutes. All you need to do is how many servers you need it in the Kubernetes cluster, what networking to be used, etc., etc. Hosted control plane, all the UI will be given by your AKS, and managed container. So you don't need extensive experience in the container orchestration. Since you are using Azure UI itself or Azure portal itself, it will be very easy to manage. I mean, very easy means compared to the expertise required for the on-premise Kubernetes. Continuous build options, you can create a Docker images and convert them to containers right from your Azure CI/CD pipeline. Okay, and you can create resources and infrastructure inside AKS through deployment service man. You can create this, or manage your Kubernetes cluster from CI/CD pipeline as well. And most importantly, AKS is free of charge in Microsoft Azure. Means they say, hey, you can go and use AKS for free of charge. I mean, you can go and create a cluster. But the catch here is that cluster itself is nothing, right? Cluster should contain some servers, right? Your virtual machines. But those are chargeable. Okay. So someone says AKS free. It's not actually free because only the portal UI is free to use. But inside you are running a virtual machine that you need to pay. Okay. Okay, guys. I mean, those are the fundamental concepts that you need to learn uh, to create Docker images and convert them to containers and deploy them to the Kubernetes cluster, so that end users will be connecting to your applications basically or accessing your applications. Okay, I just would like to stop it for today and continue to tomorrow to start using some Docker commands and then creating clusters. I mean, Azure Kubernetes clusters and deploying your application, some sample application. Uh, are you guys clear on the fundamental concepts? Okay. So we don't have any questions. We'll stop it for today and continue tomorrow, guys.
Okay, Purna.
Thank you. Thank you.